Hi, welcome back to engineeringtalks.com. In the previous video, we discussed the analysis of plane trusses using the method of joint. In this video, we'll go through the analysis of plane trusses using the method of section. So, happy learning, and if you haven't subscribed the channel yet, please do subscribe and press the bell icon. In order to start or proceed with the analysis of plane trusses using the method of joint, we'll have to first find a joint where there are only two unknown forces. We saw this in the previous video, right? In some cases, we may not be able to find such a joint with just two unknown forces. In those cases, we can use the method of section instead of the method of joint for analyzing the plane trusses. Method of section can also be used in the analysis of large trusses like this, in which forces in only few members are required. Suppose we need to find out the forces in the members FH, HG and GI. Here we only need to find out the forces in these members. Here what we can do is that we can consider a section which passes through these three members. And this section cuts the entire frame into two parts. Now, by considering the equilibrium on any one of the two parts, we can find out the unknown forces in the members cut by this section line. While using the method of section, we must ensure that the section line passes through a maximum of three members since we have only three independent equations of equilibrium. Here all the triangles are equilaterals with sides equal to 4 meters. So, the height of each triangle will be equal to 4 into sine 60. First of all, let's find out the reactions RA and RO due to hinge and roller supports at the joints A and O. Looking at this, we can understand that RA and RO will be equal to half the total load so as to maintain the equilibrium. Now, the total load will be equal to 10 into 7, which is equal to 70. So, RA and RO will be equal to 70 by 2, which is equal to 35 kilonewton each. Now, let's consider a section like this, which passes through the members FH, HG and GI, in which forces are to be found out. This section has cut the frame into two parts. Let's consider the left part of the section. This is the left part of the section. Force in the member FH will be FFH. Force in the member GH will be FGH, whereas the force in the member GI will be FGI. Let's initially assume the directions of FFH, FGH and FGI as going away from the joints like this. Let's take moment about this joint G. So summation mg will be equal to 0 and we know that moment is equal to force into perpendicular distance. Let's assume all the clockwise moments to be positive and anti-clockwise moments to be negative. Now the moment at this joint G due to the force FFH will be positive since FFH creates a clockwise moment with respect to this joint G. And the moment is equal to FFH into perpendicular distance. Perpendicular distance is the height of the triangle which is equal to 4 into sine 60. Therefore, the moment at G due to FFH will be plus FFH into 4 sine 60. Now the moment at joint G due to all these loads will be negative since these loads create anti-clockwise moments with respect to joint G. Therefore, moment at G due to this 10 kilonewton load will be minus 10 into 10 because 10 meters is the perpendicular distance between joint G and this load. Now moment at G due to this load will be minus 10 into 6 and moment at G due to this load will be minus 10 into 2. Whereas the moment at joint G due to the reaction force RA will be equal to plus RA into 12. Here the moment due to RA is positive since RA creates a clockwise moment with respect to joint G. Now this whole thing will be equal to 0 and from this we can get the value of FFH. So FFH is equal to 100 plus 60 plus 20 minus 35 into 12 which is equal to 420 by 4 sine 60 which is equal to minus 69.28 kilonewton. Since this is negative, we'll have to reverse the direction of FFH. Initially, we assumed the direction of FFH as going away from the joint F, right? Now we'll have to reverse the direction as towards the joint F. Due to this force FH towards the joint F, there will be an equivalent opposite force towards the joint H as well. So the force in the member FH can be represented by arrows going away from each other like this. Therefore, the member FH is under compression. If you have any doubt in following this, please watch the previous video. I'll provide the link in the description. Therefore, FFH is equal to 69.28 kilonewton and it is compressive. Now we have to find out the forces in the members GH and GI. For that we have to consider the equilibrium of the forces. But before considering the equilibrium of the forces, let's resolve this force FGH into its horizontal and vertical components. So horizontal component will be FGH cos 60 whereas the vertical component will be FGH sin 60. If you have any doubts related to resolution of the forces, you can watch the previous video in order to clarify your doubts, okay? Now let's consider the equilibrium of the vertical forces. So summation Fv will be equal to 0. And let's assume all the forces in the upward direction to be positive and forces in the downward direction to be negative. Therefore, plus 35 minus 10 minus 10 minus 10 plus Fgh sin 60 will be equal to 0. Therefore, Fgh will be equal to minus 35 plus 30 by sin 60, which is equal to minus 5.77 kilonewton. Since this is negative, we'll have to reverse the direction of FGH. Initially, we assumed the direction to be going away from the joint G. Now, we'll have to reverse it so that it becomes towards the joint G like this. So, the horizontal and vertical components look like this. Now, due to this force FGH acting towards the joint G, there will be an equal and opposite force acting towards the joint H as well. So, the force induced in the member GH is represented by arrows going away from each other. So, the member GH is under compression. And the compressive force FGH is equal to 5.77 kilonewton. Now, on considering the equilibrium of the horizontal forces, that is summation FH is equal to 0, we'll have plus FGI minus FFH minus FGH cos 60 is equal to 0. We know that FGH is equal to 5.77 kilonewton and FFH is equal to 69.28 kilonewton. Now we can get the value of FGI. So FGI is equal to FFH plus FGH cos 60, which is equal to 69.28 plus 5.77 cos 60, which is equal to 72.17 kilonewton. Since this is positive, we do not have to change or reverse the direction of FGI. So it is going away from the joint G, and due to this force FGI going away from this joint G, there will be an equal and opposite force going away from the joint I as well. Therefore, the force induced in the member GI can be represented by arrows coming towards each other, which means that the member GI is under tension and the tensile force FGI is equal to 72.17 kilonewton. Please do like and share the video and subscribe the channel. Thank you.